So now that we are the masters of completing the square, I'm asking you to complete the square of the general formula. That is, if I have an equation, a x squared plus bx plus c is equal to 0, I would like you to complete the square and solve for x. And I will just give you the result. X is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now this is going to be really incredible simply because this formula here, it's called the quadratic formula. And what the quadratic formula really does is you plug in the coefficients a, b, and c of an equation in general form, and you'll get the solutions to the equation. So let us start by completing the square of the equation ax squared plus bx plus c is equal to 0. The first thing that I need to do is I need to isolate my x's, or that's what I'm going to choose to do. So I'm going to isolate my x's by subtracting c to both sides. The next step I'm going to do is I'm going to divide both sides by a. And if you divide both sides by a, now this is a real important move, is that when you take this middle term bx and you divide it by a, just write it as b over ax. And it makes the math a little less confusing just by this little subtle move. So I divided both sides by a. Now, if you notice, what I have here is the conditions necessary for completing the square. After all, we're solving this by completing the square. So we need to create a perfect square factor. And I'm just going to rewrite this down, and perhaps I'm going to have to maybe work a little bit here. So over on my right-hand side, I'm going to ask myself, well, what must I add to make this a perfect square? Well, I take my middle term, b over a, and I divide it by 2, or multiply it by a half. Same thing. So b over a times a half, and I square that. It's just showing a little bit of work. That will be b over 2a, and we're going to square it. So really, this constant term that I add is going to be b squared over 4a squared. So I'm just going to add that term here, and maybe in a nicer, brighter color. So then I'm going to add b squared over 4a squared to both sides. Now, right about here, we're starting to get a sense of how our equation is shaping up. Remember, I'm trying to shoot for something to look like this. So I'm going to continue the process. I'm going to factor the left-hand side. And that factors into x plus b over 2a. Now recall that the left-hand side was a perfect square, and so it'll follow a perfect square pattern for factoring. Now my right-hand side is negative c over a plus b squared over 4a squared. And really, on my right-hand side, typically, we don't have a common denominator, so we need to create a common denominator. My common denominator will be 4a squared. And so that, how do I make my denominator of minus c over a 4a squared? Very simply, I'm going to multiply by 4a. So I'm multiplying both top and bottom by 4a. And right about now is when you're starting to see the real big flavor. Do you see this term here? Under the radical, it's b squared minus 4ac. And if I just simply multiply out what I got going so far, so the left-hand side stays the same, but the right-hand side, I could write this as negative 4ac over 4a squared. Sorry, this was a plus b squared over 4a squared. And this is really starting to shape up. So I'm just going to take one more move, and I'm going to write this as x plus b over 2a squared is equal to b squared minus 4ac over 4a squared. Now, this is important. Let's look at the destination that we're shooting for. My final result is going to look like this, hopefully, if I've done things right. And if you take a look on the right-hand side here, my numerator is b squared minus 4ac. This is very promising indeed. So I'm just going to continue on with my work. We have the square factor is equal to b squared minus 4ac all over 4a squared. So I'm just going to get rid of some of the stuff if it decides to disappear. There it is. That's the step that I left off at. So now I have a perfect square factor on the left-hand side. My right-hand side is something interesting. But hold off. I'm just going to take the square root of both sides. So the square root of the left-hand side is x plus b over 2a. The square root of the right-hand side, now don't forget to take your positive and negative roots, is b squared minus 4ac all over 4a squared. So we're almost there. So I'm just going to maybe start to clean up a little bit of the mess here, and I'm just going to apply the square root to both the top and the square root of b squared minus 4ac all over the square root of 4a squared. So I'm just going to distribute the square root to both my numerator and my denominator. So I'm just going to clean this up just ever so slightly. Now b squared minus 4ac is not a perfect square. So I can't take the square root. However, in the denominator, it's the square root of 4a squared. Well, the square root of 4a squared is actually 2a, because 4a squared is a perfect square. Now, I'm almost home, by the way. This is good. So I'm just going to subtract b over 2a to both sides. And I'm almost at my destination. And I previously said this is what we're going to shoot for, and our final thing or our final destination, our final result that we want to get is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Wow. I apologize, but this is the quadratic formula. This quadratic formula enables us to solve any equation in this form: ax squared plus bx plus c is equal to 0. I can write even, therefore, the solutions to ax squared plus bx plus c is equal to 0 are x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's really all there is to this. All I have to do is take my values of a, b, and c, plug it into the formula, and I will solve any quadratic equation.